Welcome to the deep dive. Today we're looking at something that honestly is the absolute backbone of keeping critical facilities running when no one's there.
Exactly. We're talking about enterprise resilience.
Specifically, we're digging into the NTI E-16D-48VDP system, and our mission is to understand how this little box is so much more than just a fancy thermometer.
It really is. It's the difference between just logging data and, actively managing a crisis. This thing is watching for the whole spectrum of physical threats: temperature, water, smoke, power surges, you name it.
Okay, so let's break down how it does that. I see it has this layered sensor approach. It starts with three internal sensors.
Right, inside the box itself. It's got temperature, humidity, and it's also watching the mains voltage.
Right.
But that's just the start.
The real power comes from the external connections, I'm guessing.
That's where the intelligence is. You have 16 configurable sensor ports. These are RJ45, like network cables, for things like liquid detection, vibration, even glass break sensors.
And then there are these 8 digital inputs. What's so special about those?
What's fascinating there is their simplicity. They are just listening for a contact closure.
So a simple on or off signal. Is a door open or closed? Did a basic flood sensor trip? That kind of thing.
Precisely. It makes it incredibly versatile. And you can scale this up for a huge facility.
How so?
You can daisy chain up to 5 of these units together, one master, 4 slaves. They talk over an industrial link, RS-485, and can be up to 4,000 feet apart, all managed from one place.
Wow, okay. But managing that scale means your communication has to be flawless. What happens when something goes wrong? It sends alerts, obviously, email, SNMP, the usual suspects.
It does all that, yes. But the real question is, what happens if your network goes down with the crisis?
Exactly, that's the nightmare scenario.
And that's where the system earns its keep. It gets analog. It can trigger a physical loud alarm beacon or a siren.
So you get an audible alarm on site.
You do. And more importantly, it can use an external modem to send SMS text messages directly. It can even make actual voice phone calls with an automatic dialer. The alert gets out no matter what.
But it doesn't just scream for help, right? It can actually fight back. I'm seeing 4 output relays here.
Yes, that's the active response. Those relays can control other devices. They can turn on backup cooling, cycle power to a stuck piece of equipment, anything you can switch electrically.
And that can be triggered automatically.
It can, either by a remote command or, this is the core innovation, by what they call smart alerts.
Smart alerts. Okay, let's unpack that. This is the combination logic, right?
Exactly. You can set up alerts based on multiple conditions.
Right.
So you don't just get an alert if the room hits 90 degrees.
You want an alert if the room hits 90 degrees and the system's own internal battery starts to drain.
That's it. Because that combination signals a true emergency. And that logic can trigger some powerful actions.
Like what?
It can send SSH commands directly to your servers or network gear. So if a critical temperature is breached, it can tell a server to initiate a graceful soft shutdown on its own.
Wow. That could save you from catastrophic data loss.
It buys you critical time.
And on the integration side, the box itself runs Linux, so it fits right into the IT environment. It even works with open source tools like Nagios and MRTG.
Right, and it can become a watchdog itself. It can ping up to 64 other IP devices on the network to make sure they're still alive.
And you can even see what's happening. It supports IP cameras.
It does. You get a single web page where you can see the temperature, the humidity, and a live video feed right next to it. And yes, if a door sensor is tripped, it can automatically save a video snapshot of that moment.
Incredible. And it's built to survive, too. Internal battery, optional dual power supplies, strong encryption on all its communications.
It's all about redundancy. The system is designed to be an autonomous administrator for your physical infrastructure. It reduces the need for a human to be constantly on watch.
So that brings us to the final thought. Consider the massive implication of that. You have the ability to manage hundreds of sensors, to remotely power cycle devices, to trigger soft shutdowns across a huge distributed network, all from a single screen. So what level of human crisis intervention does that kind of comprehensive automated control truly replace?